The screen is a very important part of the screen printing process. I mean, we don't call it press printing or ink printing or squeegee printing, we call it screen printing, and it's the screen that actually makes the print. So to start the screen making process, we're going to start by looking at the darkroom where the majority of the process happens, and then looking at the screen itself. A screen printing darkroom is a very important part of the screen making and screen printing process. The emulsion we use to coat the screen and expose our image onto it is UV light sensitive. Because of this UV sensitivity, your darkroom needs to be, first and foremost, free of UV light. There are a lot of different ways to go about setting up a darkroom. It can be something as simple as a bathroom with the lights turned off and a light-safe yellow bulb to see what you're doing. Or it can be something as advanced as what you see we have going on here in the Ryonet darkroom. Here in the Ryonet darkroom, we're fortunate enough to have plenty of space as well as airflow and ventilation to do all the screen making and screen cleaning processes right in one room. If you have a smaller room, however, you can separate a lot of the wet and dirty processes outside of the darkroom. In the video, we'll identify the UV light safe processes that need to be done in a darkroom as we go along. There are three main things to think about when it comes to setting up a darkroom. First and foremost is light. Remember, our darkroom needs to be UV free and light safe. We can do this in a normal room a couple different ways. First of all, if we have a window, we can put some blackout shades in that window and use a light safe yellow bulb. Or we can use this product called Rubylith. This lets light in, but it makes it UV free. To light the darkroom during production, you want to use UV free lights. There are UV-free options for fluorescent, LED, and incandescent bulbs as you see here. This is a light-safe yellow bulb, which is essentially a bug light. If you have fluorescent tubes, you can buy UV filters for these tubes. All of these products are available on screenprinting.com on the darkroom page as well. If you don't want to replace the regular lights in your space, you can add a few light-safe bulbs in light cans or clamp lamps for easy use during light-safe activities. I prefer to have a full light-safe room like you see here so we don't have to worry about any UV contamination. The good thing about emulsion is while it's light sensitive, it's not super sensitive, and you can get away with opening the door or turning on a standard light for a few seconds without too much of a problem. The key is to avoid direct light or sunlight for extended periods of time. The second thing is the air in the environment. Humidity, airflow, and heat can affect your emulsion. Emulsion is made up of quite a lot of water, so you need a dry environment in order to dry out that emulsion once it's on the screen and really set it before you expose it. Ideally, you want your darkroom to stay under 40% humidity. For the drier areas of the country, like let's say Las Vegas, this shouldn't be a problem. However, for the more humid areas, you definitely want a small dehumidifier to suck out the water from the air. Without this dry environment, your emulsion will stay wet on the screen. This will decrease your quality and increase your inconsistency. Along with the dry environment, you will also need some airflow. This can be accomplished simply and cost-effectively with a few box fans. If you have the ability to vent the room with a ceiling fan, it's always a great idea to help create airflow and suck out moisture. As far as temperature goes, the ideal temperature for your darkroom is between 70 and 80 degrees. It can be a little bit hotter or colder as long as it's dry. In the wintertime, a small heater works great. In the summertime, if you have AC, that's great too. It's best to keep your washout booth or sink separate from your exposure area. In this case, we do have both in the same room. It's not an issue for us because of our dehumidifiers and fans and the fact that we keep them fairly far apart. The third is cleanliness. Your darkroom should be considered a clean room, and the cleaner it is, the less variables you'll have to deal with in the screen making process. In the Ryonet darkroom, we have sealed concrete floors that are easy to clean, as well as casters on everything so we can roll them out of the way and clean the dust bunnies easily. We recommend cleaning your darkroom regularly. Now that we've got our darkroom set up and ready to go, let's talk about how to choose the right screens for our print job. A screen is made with a frame that has mesh stretch across it. Historically, frames are made with wood and meshed with silk, thus the previous name for our industry, silk screening. Today's frames are mainly made out of aluminum and the mesh is a polyester thread. These are stronger and will last longer. While some printers still do use wood screens, they don't last as long due to the wood warping when chemicals and water are introduced to it. The goal of the screen is to hold your image and the ink and release your ink from the mesh to make your print. Frames are typically either static or retensionable. Retensionable screens allow you to roll or clip on the mesh and tighten it again, as you see here with the Ryonet Solid Lock screen. This gives the screen printer more versatility and makes great screens, but also does take a little longer and involves a larger investment up front. Static frames hold the mesh onto the frame with glue, traditionally made by a screen maker and bought pre-stretched. In this video, we're going to be using mainly static frames made by Nortec Graphics right here in the USA. We'll also be using a few solid lock frames for our advanced prints. While the frame holds the mesh is what does the work. And there are 4 things to consider when picking mesh. The first is thread count. Thread count is how many threads cross per square inch. 110 mesh equals 110 cross sections per square inch. The higher the mesh count, the smaller your threads and the holes get. Lower mesh counts let more ink through and are typically used for thicker inks, heavier coverage, and low detail. High mesh counts let less ink through and are typically used for thinner inks and higher detail. Let's nerd out for a second and talk about thread diameter and micron opening of the mesh. Now, thread diameter is how thick or thin your mesh thread is. So if you have a thicker thread measured in microns, you will have a stronger mesh, but slightly smaller holes. Advanced meshes use a thinner thread count, which creates a wider micron opening of the mesh. This gives you the best of both worlds, but does create a more delicate mesh. For most screen printers, a standard mesh will work just fine, especially if you're just starting out. It's also a little stronger, and you don't have to get into the science of it right away. Finally, we have your mesh tension. This is how tight the mesh is stretched. A screen is like a trampoline. If you have a tight screen, it will bounce better and essentially release the ink better onto the garment. Screen tension is measured with a cool tool called a tension meter in a measuring unit called newtons. Typically, you want your screens above 18 newtons and ideally above 20 newtons. Advanced screens are stretched tighter to give you a better print. As the screen gets older, it loses tension, and it is important to use the same tension of screen for the same job, meaning use all new screens or all old screens, but not new and old screens together. Screens can last for years and hold thousands of prints, so it's a great idea to date your screens when you get them. Also, as you get more screens, investing in a tension meter is a great idea because it tells you what screens to use and what screens not to use for similar jobs. Choosing your mesh correctly is important when it comes to making a great screen. You can do all the right things and burn it on the wrong mesh, and blammo, your great print just turned mediocre or worse. For this video, we're going to use the art and the prints that we're going to be doing in the video to illustrate the thought process for selecting the correct mesh for your job. There are two main things that we consider when choosing mesh, and that is the ink and the detail of the print. You'll see how they come very close together and work with each other in choosing the correct mesh for our jobs. The ink you choose is dependent on the type and color of the fabric you're printing on. Darker fabrics need thicker, more opaque inks or a white underbase. White ink is thick due to the pigment load of the ink in order to make it opaque enough to show up on dark garments. There are also different types of inks for printing on different types of fabric. Polyester fabric, for instance, absorbs more ink and has dye migration issues, thus the ink typically printed on it is a little thicker. Some inks have particulates in them, like glitter and metal flake, that give it a special effect. When it comes to the ink and the mesh, it's about laying down the proper amount of ink. Thicker inks usually require a lower mesh screen. This is especially true when laying down white ink onto dark garments. The mesh of a screen to a screen printer is like a paintbrush to an artist. The finer strokes you have, the finer brush you're going to need, and for a screen printer, the finer detail your art is, the higher mesh you're going to need. For detailed line artwork, like with halftones, we typically measure the detail in LPI or lines per inch. The higher the LPI we go, the higher the mesh we're going to need to expose it on, in order to retain and hold that detail. There's a simple equation to understand the detail and mesh for your print. For your standard multi-source exposure units that have more than one bulb in them, take your LPI and times it by 5. This equals the minimum mesh count you want to expose onto. You can also take your mesh count and divide it by 5, which equals the maximum LPI you'll want to print your films at. For this design, we printed it in a 45 LPI, which means that we want to expose it onto a 225 or, in this case, a 230 mesh screen. For advanced single-point exposure units that only have one light source and a more powerful light, you can take this equation down to 3.5. Better light sources shoot the screen from a straight-on angle, allowing you to put more detail on a lower mesh. For screen printers looking for the ultimate detail and speed, it's good to invest in a high-end exposure system. Remember, it's the screen that makes the print, and a good exposure makes a good screen. The mesh count also directly impacts the hand or the feel of your print. If you want a softer print, you want to print it through a higher mesh, which will lay less ink down and leave a softer hand or feel on your garment. The first job we're printing today is a multicolor print going onto dark garments with a white underbase. For the underbase, we're going to be using Lava Low Bleed White since we're printing on 50/50 shirts. This ink is a little thicker because of the white pigment load and the low bleed properties, which we'll discuss later. So what about detail? As you can see, the detail is very basic, so there's no need for a high mesh screen here. And since our underbase ink is thicker, we're going to go on a lower mesh, which is going to be a 110. If you remember, this design does have multiple colors, an underbase, and an overprint that will be printed on top of it. Our lava colored inks tend to be a little thinner than the low bleed white inks, meaning we can use a higher mesh count. Secondly, we won't be printing these inks directly to fabric, and we're going to go on an underbase that doesn't soak as much ink up. And so for the overprint, we're going to be using a 156 mesh. Now remember, the mesh directly dictates how much ink you're using. So if you take 110 divided by 156, you're actually using about 1/3 less ink when you're using a 156 mesh screen. That means Every 1,000 shirts we're going to print, we're going to use 1/3 less gallon. And if we print 3,000 shirts, we pretty much get a free gallon of ink if we just go with a little bit higher mesh. For the final design, we're going to be doing the higher detail 45-line LPI exposed on a 230 mesh screen, as we discussed previously. For this design, we're going to be using thinner water-based inks, which work great on 230 mesh. The last thing you want to double check on your screens is how tight they are. Your screen needs to have tension in order to lift up from the printing surface and lay down the ink smooth and crisp below. A lower tension screen, like a lower tension trampoline, will require you to work harder to accomplish the same result. This is more relevant when printing thicker inks than thinner inks, just like a trampoline has to be tighter when someone who is heavier is bouncing on it. Brand new screens typically come in between 22 and 25 newtons, which is the unit of measurement that we measure tension on screens with. Our brand new 110 mesh is 25 newtons and the 156 mesh is 24 newtons. As your screens slowly lose tension from being printed, reclaimed and saved, you'll need to print simpler jobs with thinner inks which don't require as much tension to print. Tension meters are a worthwhile investment for any shop. However, if you don't have a tension meter, it's a good idea to date your screens when you get them. You can also push on them and feel the relative tightness between each mesh. It's a good idea to use newer screens with the same dates for the same job. It's not an exact science, but it will get you most of the way there. As your screen gets looser or breaks, you can always send it back for restretching. Another option to invest in is solid lock screens. These screens hold their tension longer because they clip in and allow you to tighten the mesh one time before throwing it away. And if they go bad and break, you can restretch them yourself without having to send them back for remeshing. One final note about your screens is be sure to handle them with care. No sharp objects or corners to hit them on, and don't drop them. This will help them from breaking and they will last much longer.